In this video, we'll be evaluating and graphing a piecewise defined function. A piecewise defined function is defined by different rules over different intervals of the domain. So any given piecewise defined function will be different from another one. So we're given that f of x is a piecewise defined function that equals 2x plus 4 if x is less than 1, and 4 minus x if x is greater than or equal to 1. So here we're told that x is negative 5. So to decide which rule we need to use, we're going to look at this part of the function. When x is less than 1, we use this top function. So we'll use the top rule, and we'll sub in negative 5 when we see x. So we have 2 times negative 5 plus 4. That is negative 6. So f of negative 5 is negative 6. In this one, we're asked to evaluate f of negative 1. So x is negative 1. And again, that's still the top rule. So top. And we have 2 times negative 1 plus 4, which is 2. Our next one is f of 0. 0 is still less than 1, so we're using the top rule. So 2 times 0 plus 4 gives me 4. For f of 1, notice that we have to use the bottom rule if x is greater than or equal to 1. So x is equal to 1, so we use the bottom rule. And we have to evaluate 4 minus 1, since x is 1. So this is 3. And then when x is 3, again, that is still greater than 1. So I'm going to use the bottom rule. And I write 4 subtract 3, and that's 1. Now let's look at some graphing. We're asked to graph the piecewise defined function f of x is equal to 2x plus 4 if x is less than 1, and f of x is equal to 4 minus x if x is greater than or equal to 1. So we have a boundary at x equal to 1 that causes us to change from one rule to the other. So I'm going to just draw a dotted line here, real lightly, at x equal 1, because this is the boundary. On the left side of that dotted line, I'll be graphing this top function, 2x plus 4, and on the right side of this dotted line, I'll be graphing the bottom function, which is 4 minus x. Now what I'm going to do is make a t-chart, and then I'm going to use this t-chart with y equals 2x plus 4, and then I'll make another t-chart with y equals 4 minus x. So for the y equal 2x plus 4, which is the top function, my x values have to be less than 1. So less than 1, and I'm going to include that 1 on both charts so that I can see what happens at that boundary. Okay, so I'll include the 1, and let me do 0 and negative 1. And then on this one, I'll include the 1, and then for 4 minus x, that's for x values bigger than 1, so I'll do 2 and 3. Okay, so when x is 1, I have 6. When x is 0, I have 4. When x is negative 1, I have 2. So on the left side of this dotted line, on this boundary, my x is 1, I have 6. Now, I'm not including, I can't include x equal 1. So this is going to be an open circle here at the point 1, 6, and then the point 0, 4, and the point negative 1, 2. So on the left side of my boundary, I have a line with the y-intercept of 4, which I can see from my graph, from my function, and a slope of 2. Just need to be careful that the left side, you only go so far as the boundary. You don't go any further. Right. Now on this one, when x is 1, I have 3. When x is 2, I have 2. And when x is 3, I have 1. So on this part of the function, 4 minus x, I do include the point when x is equal to 1. So the point 1, 3 is included in the graph, and then 2, 2, and then 3, 1. So on the right side of my boundary, I have a line that has a y-intercept of, if I continued this up, it would have a y-intercept of 4, which I can see from this. The b of this is 4, and then a slope of negative 1, which I can see from my function.